President Trump is a total and complete dipshit.
Perhaps you've heard the news from approximately 1 year ago, but this video was created by deepfake technology using generative adversarial networks. The purpose of a GAN is to create data similar to training data. GANs can be trained to create images, 3D models of objects, videos, and audio. They can also increase the quality of images. In this video, GANs will be used to generate images. The architecture of a GAN is very unique among other machine learning models. In a GAN, two neural networks try to outperform the other. A generative model generates images that supposedly looks like the dataset, and a discriminative model tries to classify the real and fake images as a generated image or an image from the dataset. In the backpropagation step, the generative model learns from the gradients of the discriminative model. The goal of the generative model is to make the discriminator less accurate, or confuse the discriminator, so the gradients it uses are negative. While two networks are trained, the ultimate purpose of a GAN is usually to make new images using the generator, not to classify images as real or fake. The discriminator is only used for training. Both networks must be on a similar skill level to work. If either the discriminator or the generator manages to outperform the other too hard, it will be hard for the other to learn. To train a GAN to generate images is an unsupervised learning problem, meaning the goal is to learn patterns within the images. The generator starts with a random noise vector and eventually expands it into an image, using the transposed convolutional layer, among others. The discriminator is given many images from the real dataset as well as the fake images from the generator, and it uses normal convolutional layers, along with others, to classify whether it is a real or fake image. A convolutional layer works by identifying features or patterns within the image, usually to compress the image into a smaller form, while a transposed convolutional layer takes the compressed form and expands it back into the image. As the skill level of both neural networks improve, the generator will generate increasingly real images, and it will be harder for a human to tell them apart. The uses of GANs include generating more data for a training set, generating realistic images, changing styles of images, creating fake art and deepfaking, creating images from text, and many other impressive applications. Due to the intricacy of images and videos, realistic GANs may take many days, sometimes even up to a month, to train on a regular GPU. However, even then, GANs are not perfect. Slight inconsistencies, especially between frames of a video, such as flickering lights or changing colors, may show that a video was generated, or at least edited. While they are blurry and unfocused, these are some images that a GAN generated from the MNIST dataset. While GANs are an exciting new way to use machine learning and artificial intelligence to create new and realistic images, they are also a very dangerous tool. Recent scams and frauds have been accomplished using GANs, and many companies are currently taking action against them. Deepfaking videos is currently not illegal, but they are being monitored very carefully. The future depends on how this technology develops and whether it will be used correctly.